Okay, so simulation of the robot, change simulation. Let's restart tutorial 9. Oh yeah, it's starting, very good. So once more I will open graphical tools to tell you a little bit more about what is happening in the system. Let's open also RQT graph to visualize the system. Okay, so let's go. As you can see, RQT graph is quite complex. So we use out-of-the-box ready working ROS nodes here instead of this single one called Search Manager. So Search Manager is responsible for let's say performing the whole search task. Its code is quite complex. I will open it in the next few minutes and tell a little bit more about that. And yeah, we are getting data from LiDAR. Explore server is creating a map of the environment. It is and then Search Manager is controlling the movement of the robot based on the signals from RGB camera and LiDAR. Oh yes, and ROSbot once more has finished its tasks. So that's the image from the RGB camera, what you can see right now. So robot found stop sign. And yeah, so basically robot checked all obstacles, all objects that are present on that map. And as soon as it finds the target object, it stops. Let's open IDE to show you the key nodes that we developed to perform Search Manager tasks. So Catkin workspace source and Search Manager node CPP. So here's the whole source code of the node that we created. So it contains more than 500 lines of code. So I will not go much into details of how it works, but the source code is open and it is explained in details in our tutorial number 9. And yeah, we have also created a few launch files showing you how to so dedicated for physical robot, for a simulation environment, because you need to change them a little bit to adjust them to a specific environment. I think we'll done in let's say describing you in high level how the system works. So now let me tell a little bit about second half of our tutorial. I will demonstrate you together with you, Łukasz, how to connect that simulation environment with the physical robot. We will need to have a physical robot, of course, and this physical robot is present in my home right now. Łukasz is present somewhere else, and Łukasz will connect to the robot from the level of his own ROS development studio environment. And show you how to open run the same tasks as I did before in the simulation environment. Let me show you how to do that from the level of ROS Development Studio. In the ROS Development Studio, you will find a button Real Robot. So let's connect that. And you can see connect ROS.ds to a real robot and provided by Husarion. So let me tell a little bit more about how connection between simulation environment and development environment and physical robot is done. So basically, that simulation environment and robot will be in the same VPN network. Problem with classical VPN network is that latency is many times too high, and they do not work well with ROS. It's quite complex to make working typical VPN solutions with ROS, and with high latency, it's also much harder to do. The connection is provided by Husarion. Husarion is a peer-to-peer VPN network, so the latency between simulation environment and robot is as low as possible. So that's direct peer-to-peer link, so you don't need to worry about too high latency. Right now, Łukasz will share his own ROS.ds environment with you. But at first we need to open a server working on a physical robot that allows you to connect to the simulation environment. So IP address of the robot is in my Wi-Fi network is as follows: is 192.168.087, right? And on port 3000 there is that website, and on that website you can configure the robot name and generate a link. So robot is right now probably connected to the environment of Łukasz. So Łukasz, can you share your desktop right now with us?
And share my desktop. I think you should see it now.
Yeah, we can hear. We can see you. Yeah, Lucas.
And I can start working with my desktop. It's already connected. Yeah. We can see that I'm already connected with ROSbot. It's connecting to connect with. I'm providing the default by start the launch file, which is supporting the leader, the camera, and all the device, all the controllers in the ROSbot. This is the launch file, which is dedicated for ROSbot part. Now I'm opening the additional terminal. In this one, I will start the launch file required for opening AirViews and graphical tools for the LDS side. At this moment, the ROSbot is already working. The leader should be taking the scans and camera taking the pictures. On the terminal, you can see that the map is being updated. Now we'll start. We'll start the search manager, which will manage the setting the goals for ROSbot. Okay, it's starting, so now we can switch for graphical tools.
So guys, I just changed.
Okay, we are seeing the dervis and environment where the ROSbot is located. You can see that there are scans from the leader, and now we've got the map appeared. So in the moment, ROSbot should start searching. Yeah, we can see how it moves. And in a moment it should, I think it will find the object.
Yeah, and I'm streaming the image showing how robot is performing its tasks right now. Yes, so Łukasz, maybe tell a little bit more about this color in the RVs.
Okay, you can observe how as the ROSbot is traversing through the environment, the pink areas which are being marked are the obstacles that have been already checked by ROSbot, and they're marked as there is no search object. And as the ROSbot is moving further, it will search all the obstacles to check if there is the object we are searching for.
Oh yeah, he did.
So we can see now that the objects have been marked, so the ROSbot have found the search object is the stop sign, and that's the finished task.
Yes. So
I think we can switch back to the Dominik.
Yeah.
Okay, thank you.
I can apply to share my songs.
Great.
Lost. I can apply.
Yeah, and the whole time I was streaming the image, how the robot is performing in the physical environment. I'm not sure whether you have seen it.
Yeah, we have seen it. We've been streaming Lucas and your image, both.
Okay, perfect. So as you can see, we can run that simulation, that code both in the simulation environment and on the physical robot in a very similar way. And that's very good because we can iterate really fast in the simulation environment with our source code, and then one to one we can move the same code to the physical robot and see that the algorithm is performing the same way in simulation and in real environment, and it's great to see that. So the project, the source code was very complex to analyze that line by line, but all attendees has got access to the detailed tutorial describing all important let's say file and function. But as you can see, the robot is performing well. It did its tasks, but of course you can add new functionalities to that tutorial. That the robot, for example, could have a web UI in which you can send photos of objects you'd like to let them find. So it would be a very nice robot solving real life problems, because all of us sometimes has lost something, so such devices could be really useful.
Okay, great, thanks, Dominic.